Assalamualaikum and hi guys. Today we will start chapter momentum. So first thing first, what is momentum? Okay, in this chapter you will learn about, I will explain briefly about momentum and then how to calculate momentum. Okay, so first of all, what you need to know for momentum is all moving objects have momentum. Why? Because they have mass. Okay, but if an object is not moving, then its momentum is zero, even though it has mass. Okay, please remember this or understand this concept. So all moving objects have momentum, but if an object is not moving, then the momentum is zero. So next, how to calculate momentum? So momentum, the symbol of momentum is P with an arrow, means it's a vector quantity. Okay, so how to calculate momentum? Momentum is equal to mass times with velocity. P is equal to mv. P is the symbol for momentum, mass, v is velocity. Mass, P is momentum, V is velocity. Sometimes they will use speed. Okay, what is the unit for momentum? So you just express from the equation itself. So momentum unit is mass is kilogram, velocity is meter per second, or you can write as kilogram meter per second. It depends on you. It's all same. Okay, next, conservation of momentum. Conservation of momentum to show that initial momentum is equal to final momentum, which is momentum initial is equal to momentum final. Okay, there will be two objects if there's a momentum. For example, one object hit to one object, so there will be a momentum. So m1 v1 initial plus m2 v2 initial. Okay, some of you will assume v initial is u, right? So either you can use m1 u1 plus m2 u2, or m1 v1 initial velocity plus mass number 2 with the initial velocity number 2. Okay, is equal to m1 v1 final plus m2 v2 final. This is what we call as conservation of momentum. Okay, next, we will derive Newton's second law for average force relate with the momentum. Who wants to derive? Only 3 steps of it. Okay, first I want to ask you, what is Newton's second law? You learn in laws of motion. So Newton's second law is equal to total force is equal to ma. Is it correct? So we derive this equation until you get momentum. So force till force, you can even use F is equal to mass. Acceleration you can expand on it. Very good. Acceleration is delta V over delta T, change of velocity over change of time. It means V final minus V initial, change of velocity, over T final minus T initial, if you want to expand. Okay, so relate with the momentum. We know that P is equal to mv, so here will be your m times v. So you can conclude that F is equal to delta P over delta T. So delta P is the change of momentum over change of time is equal to average force. Okay, now we relate with impulse. What is impulse momentum theorem? Impulse. What is impulse? Okay, when there's a change of momentum, there will be an impulse. So impulse, the symbol is I. Impulse is equal to change of momentum. As easy as that. is equal to change of momentum if you expand mv final minus mv initial. Then if you factorize the equation, you will get mv final minus v initial. Or even can relate with the force. Change of momentum T bring to left hand side, so you will get Ft. Ft is equal to change of momentum. So F times T. F times change of momentum. So all of this equation you can use in impulse momentum theorem or impulse momentum application. Okay, if there's a force given, so you use force equation. If you want to find impulse but you are given velocity, so you can use either this equation or this equation. It depends on the question given. Okay, so if you are given force versus I think this one is t, not x, time. Okay, x component. Okay, if F versus t, what is area under the graph? F versus t graph, what will you get? Change of momentum. Very good. Change of momentum is equal to impulse. So area under graph is equal to impulse or change of momentum. Same definition, Okay. What if I give you this one out of this topic? F versus x. What is area under graph? You have learned in work, energy, and power. F versus x, what did you get? Very good. Work done. Okay. Okay, next. We go to the example. Okay, example 1. Please read the question carefully and highlight what is the information given here. Okay, a 60 kilogram archer stands at rest. So 60 kilogram is the mass number 1. Okay, a 60 kilogram archer stands at rest on a frictionless ice and fires a 0.5 kilogram arrow horizontally at 50 meters per second. With what velocity does the archer move across the ice after firing the arrow? Okay, first, what information you have there? Okay, archer. Okay, how many mass? How many object you have here? 2, right? Which is archer hold the arrow. Hold the arrow. So arrow will be the mass number 2. So here 0.5 kg is M2. Stand at rest. So both of the archer and the arrow stand at rest, right? The archer hold the arrow and stand at rest. So V1 initial is equal to V2 initial. Velocity initial for the archer and velocity initial for the arrow is equal to 0 because at rest. Okay, when you see this keyword, at rest means is equal to 0. Horizontally at 50 meters per second. What is 50 meters per second? V1 final or V2 final? Okay, read the next question. With what velocity does the archer move across the ice after firing the arrow? It means this is the arrow velocity. So V2 final. With what velocity does the archer? So here will be your archer velocity. V initial for archer. Archer is number 1. Okay, mass number 1. So you have 2 object, you have 2 velocity. So what equation you want to use here? Okay, good. We will use the equation conservation of momentum. But before that, if you can draw. This one is the archer, M1. Here will be the arrow, M2. Okay, at first place, M1 and M2 is together. So V1 and V2 inertial is equal to 0. This is before. Okay, after, before, okay, sorry for the short form. Okay, after, so after the mass 1, we don't know going to the left or to the right. So mass 2, firing the arrow with 50 meter per second. Here will be V2 final. You have to find V1 final. We doesn't know whether to the left or to the right. We will look after we calculate, okay? So you said you want to use conservation of momentum. So we use M1 V1 initial plus M2 V2 initial is equal to M1 V1 final plus M2 V2 final. Okay, because both of the velocity initial at rest, so you can cancel out everything is equal to 0. 0 times everything, even plus with the 0, is equal to 0, right? So 0 is equal to mass number 1 is 60 kilogram. Velocity 1 final, we don't know, so we have to find. Plus mass number 2, arrow mass is 0.5. V2 final is equal to 50. So after you calculate with your calculator, you will get V1 final is equal to negative 0.4167 meter per second. Okay, what does it mean by negative? Okay, negative means the mass number 1, means the person itself, the archer, goes to the left. Negative means go to the left. So we know that after the archer fire the arrow, he will move to the left. Okay, if he move to the right, the velocity will be positive. Okay, clear? Okay, good. Okay, next example. A box of Tic Tac. Do you know what is Tic Tac? You can have a Tic Tac while you're watching my video. Okay, so a box of Tic Tac 15 gram is sliding along a table at 5 meter per second. So I tried to stop it, but only slow it down to 1.6 meter per second. Determine the impulse. Impulse means change of momentum that I impart to the box. Okay, so what you need to do is to take out the information given. So a box of Tic Tac 15 gram, here will be the mass. Mass as I unit kilogram, please remember that. So 15 divided by 1000, 1, 2, 3 is equal to 0.015 kilogram mass. Okay, it's sliding along a table 5 meter per second. So 5 meter per second will be your V inertial. Okay, because there's only one object, so 1. Okay, I tried to stop it, but only slow it down to 1.6 meter per second. So 1.6 will be your V final. Determine the impulse. So impulse, what's the equation for impulse? You can choose either one of these equation. How to find impulse? You can use change of momentum, then you expand into this, then you can use force times time. Okay, but you have to look at the information given. Information given, you have initial velocity, final velocity only with the mass. Okay, so you have initial velocity, final velocity, and the mass. You can use this equation. Instead of you use F times T, you don't have force given. So use the easiest and directed one. So you use impulse is equal to mv final minus v initial, or even you can use this one. Better use the simple one, okay? Okay, so I will use I is equal to change of momentum and expand mv final minus mv initial is equal to mv final minus v initial. So mass is equal to 0.015 after you convert into kilogram. V final is 1.6 minus 5. So after you calculate, what's the answer? negative 0.051 kilogram meter per second. The unit of the impulse of or momentum are same, which is kilogram meter per second. Okay, you just derive from the equation given. Okay, next, example 3. Calculate the magnitude of the linear momentum of following cases. So the first one, you have a proton of 2.8 blah blah kilogram. So here will be the mass moving with the speed of this one. So if you don't know, if they said, if the question just stated that moving with this one, so do you know what is this? Very good. You have to look at the unit. If meter per second, of course that's a speed or velocity. Okay, so here will be V. Calculate the magnitude, the value of momentum. So the first one, how to calculate momentum? P is equal to mv, as easy as ABC. So momentum is equal to mass, substitute the mass, velocity, substitute the velocity, then you get the answer, kilogram meter per second. Okay, for question number 2, same with the previous one, how to find the linear momentum. Linear momentum, just a direct question, which is P is equal to mv. So for all question, you can use the same equation like this. Okay, but not to forget to convert this gram into kilogram. Alright, anything you have to convert into SI unit. If they're given you velocity in centimeter per second, how you do it? You have to convert or not? Yes, of course you have to convert. Okay, you have to convert everything into SI unit. Okay, now we move to the next topic, which is not the next topic, the next example actually. Okay, example 4. In a particular crash test, an automobile 1,500 kilogram collides with the wall as shown in figure. So here is the figure. Here will be the 1,500 car as shown in figure. Initial and final velocities are negative 15, or actually, sorry, this one is I. Why I? Because, why? Because the car move on the x-axis. I to show x-axis, J to show y-axis. Remember in vector? Okay, good. Okay, so V final 2.1 I meter per second. It's to show that this car move in y-axis only. Okay, I and I. If the collision lasts for 0.15 seconds, so here will be the time. Find the impulse and the average force. So you have to find I, you have to find the average force. So you are given the velocity, you are given the time, you are given the mass. So what equation to find impulse? Okay, you know that how to find impulse. Impulse is equal to change of momentum is equal to change of momentum, initial, it's equal to mv final minus v initial. Okay, is equal to ft. So here will be the impulse momentum theorem. So how to find impulse? You are given v initial and v final, so you can use this equation. So I is equal to mv final minus v initial. So I is equal to 1,500, 2.6, this one, v final, minus negative 15. Because here negative, okay, means to the left. So I is equal to 26,400 I. Means it move in the x-axis, unit kilogram meter per second. What if you forget to put I? Is it correct? Yes, it's still correct, because both, all application here only consist in x-axis, not in y-axis. Okay, next, average force. So you have to find force. You get the impulse value already. So you just use I is equal to ft. So to find f is equal to I over t. So f is equal to 26,400 over times 0.15. So answer 176,000 I. So unit for force, Newton. Easy. Okay. So here you get 1, 2, 3, 4, 5. Oh, sorry, this one seam. 5, 6. So 6 marks. Very easy question. Okay. So we will go to the next topic, subtopic, which is collision. Collision will meet you in the next video. Thank you very much.